For the first part of the unit, we looked at sequences. So here's the warm-up for today. Consider the sequence 1, 2, 3, 4, 5. Is this arithmetic or geometric? Circle 1. What is the common difference or common ratio? Circle 1. Find the sum of the first 2 terms, find the sum of the first 4 terms, find the sum of the first 8 terms, 100 terms, and so on. So a sequence, if you remember from chapter 1, is an ordered list of numbers. And if it's arithmetic, you're adding or subtracting to get to the next term. If it's geometric, you're multiplying or dividing. So this one is pretty one each time. So arithmetic, which means it has a common difference. And the common difference would be 1. We're adding 1 each time to get to the next term. The sum of the first 2 terms, 1 plus 2 is 3. The sum of the first 4 terms, 1 plus 2 plus 3 plus 4 is 10. You could figure out the sum of the first 8 terms. How about the sum of the first 100 terms? Now, unless you found a pattern, this might take a little bit of time to figure out the sum of the first 100 terms. Well, Carl Friedrich Gauss actually figured out a pattern for finding the sum of the first 100 terms, and in class we watched a video on the story of how he did that, but to save time I will show you in this podcast. What he did is he found a pattern. He figured out that if he wrote all the numbers in order, so 1 plus 2 plus 3 plus 4, all the way up to 100, and then if he reversed it, so 100 plus 99 plus 98 plus 97, all the way down to 1, and if he added those together, the sum of each of the terms equaled 101. Now if you think about this, how many 101s would you have? Well, you would have 100 101s. So the sum, I'll write it up here, we do the first term, which is, well actually let's do it this way first. So we have 101, 100 times, but if you remember we wrote out each sequence twice, so then you would divide that by 2. So again, to figure out the sum of the first 100 terms, you could do 101 times 100, divide by 2, and if we do that, we would get this. And if you divide that by 2, let's see, that would be, well, let's just do the long division here. 2 goes into 100 5 times. Carry down the 1, put a 0 here. 2 goes into 10 5 times. So it would equal 5,050. So the sum of the first 100 numbers would be 5,050. Again, to get that number without a calculator, you could list all the numbers from 1 to 100 and then go backwards, add them all up. There's 100 of those 100 ones, and since you listed it out twice, you would divide by 2. So we can use that pattern to write the formula. So a better way to find, a better way to find any partial sum for an arithmetic sequence is this formula. The sum for any number of terms, S sub n, would be first term plus the last term times the number of terms. So this would be like...
Good morning, staff. The 9th grade teacher meeting is already starting in room C350. If you could go to room C350 for the 9th grade teacher meeting. Thank you.
So again, think back to Gauss's formula. He did 1 plus 100, first term plus last term, times 100 because there were 100 terms, but then he had to divide by 2 because he wrote it out twice. So here n is the number of terms that you want. U sub 1 is the first term, like it was in chapter 1. U sub n is the last term. And again, n is number of terms. So this is what we're going to practice today, using this formula to find the sum of any arithmetic sequence. quick review. Sequence versus a series. A sequence is the ordered list of ordered list of numbers, and the series is the sum. So series is the sum, sequence is just the list. Here are several examples that you'll see. We have the sigma notation, which is a Greek letter that stands for the sum of. So this is saying, here is your rule here. It's linear, has a slope of 3 and a y-intercept of -1. Can you find the sum of the first 5 terms? And there's a few ways to do it. We could list them all out, or we could use the sum formula. So I'm going to show you both methods, and of course you would choose the easier method or the faster method to solve. So the first method is to list them all out. So the first term would be 3 times 1 minus 1, and 3 times 1 is 3, minus 1 is 2. The next one, we would plug in a 2 here, so 3 times 2 is 6, 6 minus 1 is 5. For the next term, we would plug in a 3 for n, 3 times 3 is 9, minus 1 is 8. And here the slope is 3, so really we're adding 3 each time, so 8 plus 3 is 11. And we need the next term, so 11 plus 3 is 14, or it's the same as 3 times 5 minus 1. So we could list them all out, and then the series, for the series you would add these all together. So there's one way you could find the sum of a certain number of terms, list them all out, and add them together. Or we could use our formula. So if you remember, our formula is first term plus the last term, in this case the last term is 5, times the number of terms. And we have from 1 to 5, 1, 2, 3, 4, 5, that is 5 terms. To get this number right here, 5 terms, you can either count 1, 2, 3, 4, 5, or it's the same as 5 minus 1 plus 1 will give us 5, and we're going to divide that by 2. So we're going to plug in, the first term was 2, the last term was 14. To get that, we plug in a 5 here. 3 times 5 is 15. 15 minus 1 is 14. Times 5, divide that all by 2. And if we do that, we get 40. So if we were to add all these together, we would get 40. Or if you want to plug into the sum formula, you would get the same answer, 40. Okay, let's do both methods for this one. Write the following as a sum of terms and then find the sum. So this is from the 4th term to the 7th term. So again, you could list out the numbers. So here it's just n, so 4. And then you plug in a 5 here. 6, 7. So here's our list of numbers we're just plugging in. Here the y-intercept is 0, and then the slope is 1, and we're starting at 4, so that's how we get the numbers. So 4, 5, 6, 7. You could add those up, or we could use our sum formula. The sum of the first 4 terms is the first term plus the 4th term, times the number of terms. And again, to get the number of terms, so you get n, you can do 7 minus 4, but then add 1. We know there's 1, 2, 3, 4 terms. 7 minus 4 is 3. 3 plus 1 is 4. So there's 4 terms. Divide that by 2. So the sum of the first 4 terms, the first term that we want, and actually I should change this because we want from the 4th to the 7th term. So it should be u sub 4 plus u sub 7. Now we're not starting at 1 this time. So the 4th term is 4. The 7th term is 7 times 4 because there's 4 terms. And then we're going to divide by 2. So the sum of 4, 5, 6, and 7 is 22. Evaluate the following. So again, here you probably wouldn't want to list out all of the 15 terms, so I'd use the sum formula. The sum of the first 15 terms is the first number plus the 15th number times the number of terms. So the number of terms would be 15 minus 1 plus 1. There's 15 terms here. Divide by 2. All right, let's do some work on the side here. U sub 1 means the first term. You plug in a 1. So 2 times 1 plus 3 is 5. We need the last term in the 15th term, I should say, in this sequence, which is 2 times 15, which is 30 plus 3, which is 33. So let's plug that into our formula. The sum of the first 15 terms equals the first term, 5, plus the 15th term, which is 33, times 15. divide by 2.
Greg Goddard.
And if you do that, you get 285.
6199. Greg Goddard, 6199.
So the sum of the first 15 terms is 285. Oops. Okay, let's try one that doesn't start at 1. So same pattern here. Oh, that's actually, it's not the same. 3n minus 5, and we're going from the 5th to the 17th term. So this one, the sum of the 5th to the 17th term, I'll say, would be the 5th term plus the 17th term times the number of terms. And here the number of terms would be 17 minus 5, but then you add 1. So 17 minus 5 is 12. 12 plus 1 is, there's 13 numbers in this from the 5th to the 17th term. Oops, I put 15 here. There should be a 17 here, not 15. And we're going to divide that by 2. All right, let's do some side work here. U sub 15, or U sub 5 is 3 times 5, which is 15 minus 5, which is 10. U sub 17 is 3 times 17 minus 5, which is 46. So let's plug in. The sum of the 5th term to the 17th term equals 10 plus 46 times 13. Divide that by 2. And so we will get, if you type in your calculator, the sum from the 5th to the 17th term is 364. Okay, a few more examples. You can try this one. So from the 21st term to the 40th term, what would that equal? And I'll write it up here. But if you want to pause and try and check your answer, this would be a good spot to do that. So the sum of the 21st to the 40th term would be u sub 21 plus u sub 40 times the number of terms. So 40 minus 21 plus 1 would be 20 terms. We're going to divide that by 2. Figure out what u sub 21 is. Oops, let's change colors. Which is 2 plus 3 times 21, which is 64. Find u sub 40, which is 2 plus 3 times 40, which is 122. So plug into our formula. The sum would be 64 plus 122 times 20, divide by 2. So that sum would be 1,860 if I did that correctly, for the sum of the 21st to the 40th term. Now that's different than this problem right here. This is a series, which is a sum. This is a term. So u sub 10 is find the 10th term, and that's just plug in. So u sub 10, the 10th term is 2 plus 5 times 10. 5 times 10 is 50, plus 2 is 52. So this is saying the 10th term in your list of numbers is 52 versus the sum where you have to add up some terms here. All right, let's apply this then to a word problem like the one we saw in Chapter 1 here. Oops. In order to apply to the word problem, let's review what an explicit formula is. So is this arithmetic or geometric? And from the plus 3, you can see this is arithmetic. And to find the first 3 terms, you start at 2, and you add 3 every time. So you have 5, 8, dot, dot, dot. To write the explicit formula, we have y equals mx plus b. M is the slope. What is the slope here? Well, it's the plus 3. But we need the y-intercept, and the y-intercept is the 0 term. Here's the first term, second term, third term. So the 0 term worked backwards. So instead of adding 3, you'll subtract 3. So the 0 term is -1. That's the y-intercept. So you have y equals 3x minus 1 is the explicit formula, and we're going to use that in our sigma notation for the next problem. So again, this problem should look familiar. We did it before when we started sequences. The school auditorium has 59 seats in row 1, 63 in row 2, 67 in row 3, and so on. The recursive formula, in row 1, there's 59 seats. For any row, you take the row before it, and you add 4 to that. The explicit formula, the slope is 4. The y-intercept is not row 1, but would be how many seats are in row 0, so subtract 4 from 59, and that would give you 55. How we use that in the equation, how many seats are in row 11? Well, for this one, row 11 would be y equals 4 times 11 minus 55. Oh. So in row 11, there would be, and there should be a plus 55, 99. I better make sure I was plus here. So there's 99 seats in row 99. How many seats are in the whole auditorium if there are 25 rows? Well, here's our sigma notation. Starting with row 1 up to 25, we'll put our explicit formula here. So really, I should put an n instead of an x, since I started with an n over here. And then to solve this, let's use our sum formula. So the sum of the first row to the 25 rows, so the first 25 rows, will be the first row plus the 25th row times the number of rows. Divide that by 2. So if you figure out how many seats are in the first row, well, we know that there's 59 seats in the first row. Plug in a 25 here to figure out how many seats there are in the 25th row. So we have 59 plus 4 times 25 is 100 plus 55 is 155. Multiply that by 25, divide by 2. And when you calculate that, that'll give you the sum of how many seats there are in the first 25 rows. If you add them together, and I got 2,675 seats. So your assignment will be the worksheet 9-1 worksheet where you'll practice these types of problems.